Good day, everybody. We have a couple of graphs here, and we're looking for a value of c here such that the two graphs will intersect at exactly one point. And you can surmise it's going to be a tangent, sort of, it will be a tangent line type problem, or just tangent. The two graphs are tangent to each other. Now, y'all, it's clear that x minus 4 squared generates x squared minus 8x plus 16. So we have to subtract that 16 away. So this will become what, plus 23? Or we're subtracting 16 away from this. So will this be 23? Yeah, 23 plus c. Okay, so we have a great deal of information already about the x-coordinate. We know that the x-coordinate has to be equal to 4. We just have to find the value of c that corresponds to that, okay? Now, the idea here is just to use the definition of the absolute value. And one thing to observe is that x plus 17 over 3 is greater than or equal to 0 on the specified interval. And that's very clear by inspection, right? You can just look at this, minus 17 over 3 to 16 over 3. So when x, this is x trapped between where this touches the x-axis and where this touches the x-axis, all right? And the x-intercepts, I guess. Okay, so that means its absolute value is just x plus 17 over 3, right? It's already positive, right? But x minus 16 thirds, x minus 16 thirds is less than or equal to 0. Right? And so remember the definition of absolute value. If the input argument, which is what x minus 16 over 3 is, if it's negative, we have to apply a minus sign to it. And that's why you see how it got reversed here to 16 thirds minus x. We just, again, appeal to the absolute value definition. Okay. Now, of course, the x's do cancel out, and we get 11. All right. And so we know that this entire expression is just flat line between these values, minus 17 over 3 and 16 over 3. All right. And 4 is between there. So that means we can just set this part right here, this part right here, just to equal to, God damn, okay, marker goes out on me so much. Okay, so we can just set this equal to 11. Okay, and then what happens here, folks? We get x minus 4 quantity squared plus 12 plus c has to equal to 0. And this, of course, implies that c has to be equal to negative 12. All right. Now, so the value of c is negative 12, and of course x is equal to 4. Now, if you guys have somebody, if you want to know why this only touched it, if you just come back up and look at this, let's see if we can look at this picture. It's going to look something like, let me just draw a picture here. Let's do, here's 0 right here in the middle. And then we'll call this minus 17 over 3. Minus 17 over 3 right here. And then this over here would be 16 over 3. It's about the same, isn't it? I mean, so close to the same. So 16 over 3. And what we know is that the graph is constantly a value of 11 from here to here. Okay. This is 11 up. This is 11 up here. Call it y equals 11 if you want. Well, it is y equals 11 on this line segment. And y'all, if you do the rest of this problem, you'll get a line that has a slope of 2x, m equals 2 here. It's not too hard. You guys can verify that by just extending what I was doing down here. And then right here, you would have m equals minus 2. All right, m equals minus 2, the slope, the gradient, the derivative. All right, now 4 is right about here, folks. You see, this is about a little more than 5. So we'll say 4 is right here. And so what you have is it's touching exactly right there. And it grows very, very fast compared. I mean, the squaring function goes ultra fast compared to, it increases much faster than these linear functions that are fixed, right? And so you can tell it's just going to be this one spot right here, -4 and 11. Excuse me. And there's no way it can happen anywhere else. All right, so in the way this graph would always hit just at, well, it could be lower, it could hit it twice. But anyway, that's the answer, folks. That's what does it. And what was the question? The question is just to find the value of c that does that. And right down here we show that it was c is equal to -12. Okay, c is equal to -12. And again, this is the quadratic version of an SMO open question where they had a linear line, it had a linear graph, and they had c position somehow like x minus c, I believe. And so this was, I guess, slightly more challenging, but it's the same kind of thing where you get this constant behavior and then the same slope acting kind of symmetrically on both sides of it. So that does it. Let me know what you thought.